What's the long form of ER model? Why it's required? Anyone? Okay, just tell me the long form. What is ER? E stands for as well as the R stand for. Yes, it is an entity relationship model. ER model is a conceptual view of a data. Entity relationship model. See, these are the important points. Please note down these points simultaneously while I am teaching to you. Hmm? Entity is nothing but what? Yes, I want answer from you now.
Things or object.
Yes, that's correct, Pallavi. Yes, these are the objects which has physical or conceptual existence. It may be a things, object like a car, computers, students, books. Okay, so it may has the physical existence or a conceptual existence. Physical existence examples are same: chairs, tables, as well as computers. And the conceptual existence, courses, flight reservation. Okay, these are the conceptual. Then entity sets. Entity set is what? Collection of entities. It's called entity sets. Okay. Next, how we can represent the entity into the ER diagram? Rectangle. We are using rectangle to represent entities in the ER diagram. ER diagram is the pictorial representation of our database. Okay, our proposed database. Okay. Next is attribute. What is attribute? Hello, am I audible? What is attribute?
Uniquely identities, each entity in entity set.
Sorry, your voice is not clear. Can you repeat, please? Hello.
Uniquely identities, each entity in entity set.
Uniquely. Each and every attribute is not have the unique identity. Okay. For example, yes, roll number is used for the unique identifications, but the name as well as the age, all these others attributes will represent our entity uniquely. No, only one attribute, one or two attributes represent the our entity uniquely. Okay, so you are correct, but it's not up to the mark. Okay. Yes. My screen is visible to everyone. Hope so it's visible. Hello. Whether the screen is visible?
Yes, ma'am.
Okay. See, these are the example of the entity sets. Hmm? Instructor as well as the student. These are the tables. That is nothing but the entity sets. Instructor as well as the student. We are on the point of the attributes. An entity is represented by a set of attributes. These are nothing but the properties which are better described to our entity. For that purpose, we require the attributes. Okay. Then we saw the key attributes. Yes, the attributes which uniquely identifies each entity in the entity set is called the key attribute. Now see over here, student is an entity. And attribute thought this student is the ID, phone number, age as well as the name. All these are the attributes comes under the student entity. But uh, if you saw clearly the name within a one college or a university, there are a number of names are similar, as well as sometimes name, surname. Hmm, These are the similar. That means they are not uniquely identifying the particular students. For that purpose, we require the another attributes which uniquely identifies the entity. That's why we are providing roll number as well as the personal ID. Okay. So, and key attributes will be unique for each student. In ER diagram, the key attributes is represented by the oval with the underlying lines. Huh? See over here, ID is the underlined. Is that clear? Yes.
Yes, ma'am.
Okay. Now move to the next attribute type, that is the composite attributes. Yes, composite attribute is an attribute that compose of many other attributes. See, it's composed of many other attributes is known as a composite attribute. That is, the composite attribute is represented by an ellipse, and those ellipses are connected with an ellipse only. See, here address is one of the attribute, okay, and street, city, state, country. These are the part of the addresses, right? That's why these are the composite attributes. Okay, are you clear with the concept? Hmm? Here, address is one of the attribute of the entity, and sub attribute or composite attributes of the address are the street, city, state, country, and which are connect to the our main strong attribute with the lines. Okay. First, we saw the key attributes. The next type of attributes is the composite attributes. Just note down these points. Draw the diagram. See, after unit 1, you have to submit your notes. You have to upload these notes. So, while I am teaching, simultaneously note down each and every point. Okay, these are the important points. Now, next is the multi-valued attributes. Multi-valued, as the name suggests, it has multiple value. That's why it's called as the multi-valued attributes. An attribute consisting more than one value. The attribute is consisting more than one value for a given entity is called multi-valued attributes. For example, phone number. hmm, Particular students have more than one phone number. That means it has a multi-value. So, phone number comes under the multi-value attributes. In ER diagram, the multi-valued attributes is represented by a double oval. Okay. Normal attribute is represented by the single oval, but if it has a multiple values, then it is represented by the double oval. Okay. So next is a derived attribute. An attribute which can be derived from other attributes. Concentrate properly. An attribute which can be derived from other attributes of the entity type is known as a derived attributes. See, let's take an example of age. If there is a one attribute age in the table of the students, so as the years goes, time to time age entity will get changed. But how we can take the exact value of the age from the date of birth? Yes, it's so simple. That means the age is the attribute which is totally dependent on the date of birth of the student. Okay, so it is a derived attribute. In ER diagram, derived attribute is represented by a dashed oval. Okay, hope so you are clear with the concept of the entity sets, attributes types. Is there any doubts how to represent it, these points into the diagram? If is there any doubt, let me know here only. Because in the first assignment, you have to draw the ER diagram for the particular organization. Yes, is there any doubt? Yes, no?
No, ma'am.
Okay. Now, see over here. This is the complete entity type student with its attribute. Okay. Here, student with its attribute roll number, name, date of the birth, as well as the phone number, age. So, according to the this diagram, can I ask few questions to you, students? Why over here age is in dash oval form? What's the types of attribute? Just now you said
Derived.
yes. Who was the answer? Who
Pallavi,
told
ma'am.
the answer? Okay, Pallavi. Thank you. Correct. Then phone number. phone number is in double oval. Why? What's the type of the attribute?
Multi-valued.
Yes, correct. What's your name? What's your good name?
Pallavi Ritul.
Okay. Here the type of address. Which type of attribute address is it? सी ॲड्रेस हा एक ॲट्रिब्यूट आहे तर त्याचा टाईप कुठला आहे?
Composite.
येस, कंपोजिट. करेक्ट. See, these types of question may ask in the exam. So if you are clear with the concept over here only, then it's more easier for you only people. Okay. Let's move to the next slide. That is the relationship set. Yes. Yes. Relationship is used to describe the relation between the entities. Yes, entities, these are the things, objects. Huh? In database, the entities are related to with each other. That's why we call it as a database. If you remember the definition of the database is that the database is the collection of the data which is interrelated with each other. There should be a relationship between them. So relationship is used to describe the relation or association between the entities. Okay. A relationship type represent the association between entity. For that, diamond or rhombus is used to represent the relationship and connecting in the entities with the lines. So we are using the diamond. Okay. A relationship set is a set of relationship of a same type. Okay. Let's see an example. Here, students as well as the course. These are the entity within a university database. So in that, students enroll in specific course. That's the there is an association between the students and course is what enroll in. Okay. So we are representing the relationship using the diamond or rhombus in the ER diagram. In ER diagram, relationship type is represented by a diamond. And okay, is that clear? Yesterday we also saw one example. Employee works for a XYZ organizations. So in this example, which are the entities? Employee works for XYZ organization.
Employee and XYZ organization.
Yes. And what's the relationship in between? Works for. So same employees as well as the organization, XYZ organization, we can represent it in by using the rectangle and works for in the diamond. And these are connected with each other through the line. Okay. Now, yes, continue with the relationship set. A set of relationship of a same type is known as the relationship set. Example here over here. See, here is the student set is available. That is the student entity set. Entity set is nothing but the collection of entities S1, S2, S3. These are the collection of records of different students. Okay. As well as courses is the another entity set. C1, C2, C3. These are the different courses available in the courses entity sets. And E1 is the relationship set, that is the enroll for. Here, student S1 enroll for the C2 course. Student S2 enroll for the C1 course, like that. Okay, we are representing the relationship set, or we can set the relationship. Okay, are you clear with the concept of the relationship set, why it's required?
Yes, ma'am.
Okay, thank you. Now, degree of the relationship set. This is the one of the important point in the relationship set. So degree is nothing but the number of different entity sets. See, different entity sets participating in a relationship. Number of different entity set. If you take this example, the how many entities are participating over here? Student entity as well as the course course entity. That's mean these are the two entity sets. So the number of different entity sets participating in a relationship. In previous example, two entities are participating. So what's the degree of that relationship set? It is a 2. Degree is a 2. Okay. So the number of different entities set participating in a relationship set is called as a degree of relationship set. So according to their participations, there are three categories of the relationship. First one is the unary relationship, second one is the binary, and third one is the n-ray relationship. Okay, according to the participation. So unary relationship, as the name suggests, when there is a only one entity set participating in a relation, the relationship is called as a unary relationship. Okay, only one entity is available, or only one entity is going to participate in a relationship diagram. Hmm? Then a relationship set, then we can call it as a it's a unary relationship. For example, one person is married to one person. Okay, assume one person, only one person married to uh, only one person. So this is the unary kind of relationship. Only one entity is present. That's why it's called as a unary. Now, next one is the binary relationship. See, as the name suggests, binary, that is the two. Okay, when there are two entities said participating in a relation, the relationship is called as a binary relationship. I will repeat. If there are two entities are participating in a relation, the relationship is called a binary relationship. For example, student is enrolled in a course. Hmm? Here, the student and course These are the two entities, and there is a association between the student and course is the enroll in. Hmm? So it is a binary relationship. We are defining the degrees of a relationship set. We are we are on the point of the unary, after that the binary, and now next one is the n-ray relationship. When there are n entities set participating in a relation, the relationship is called as a n-ray relationship. That means more than two entities are participating in a relation. Hmm? Then it's called as a n-ray relationship. But according to the DBMS, most of the relationship sets in the database systems are a binary. Okay. Occasionally, it may be a unary or a n-ray relationship. However, relationship sets involve more than two entities in n-ray. Hmm? So most of the relationship sets in the database are the binary. Remember these things. Is that clear? Everyone understood? Hello, are you there?
Yes, ma'am, clear.
Okay. Just now we saw the concept of the degree. Now move to the next important concept, that is the constraint. Constraint is nothing but these are the rules and regulation which we are applying on the entity sets. Okay. An ER enterprise schema may define certain constraint, hmm, to which the content of the database must be confirmed. I think you aware of these concept like set theory in that mapping, one to one to many, many to one, many to many. This is the somewhat similar kind of that is called as a mapping cardinalities in DBMS. The number of times an entity of an entity set participate, see number of time entity of an entity sets. आपण आता entity set मधल्या entity बद्दल बोलत आहोत, right? The number of times an entity of an entity set participates in a relation set is known as the cardinality. Okay, cardinality can be a different types for a binary relationship set. Okay, we are talking about the binary relationship set only. Okay, cardinality can be can be of different types for a binary relationship set. Suppose there is a relationship set R between entity sets A and B. Hmm? A and B, these are the entity sets, and R is the relationship ship set between them. The mapping cardinality must be one of the following, that is one, one to many to one, or many to many. Please note down these points as well as the definitions. All these are the important points. Ohar, let's see one by one individually. First one is the one to one. An entity in A is associated with at most one entity in a B. See over here, A and B are what? These are the entity sets, and one in an entity in a A, hmm, here A1 is associated with at most one entity in a B, in a B set. That means it is a one to one relation. Okay. Now one to many. Is there any doubt? Hope so. No. A1 is associated with B1 or vice versa. Even B1 is associated only with A1. Hmm? One to many. An entity in A C is associated with any number of from 0 to more. Now concentrate on the diagram, B diagram, one to many cardinality, and entity A is associated with any number of, that is 0 to n of entities in a B, and uh, an entity in a B however can be associated with at most one entity in a A. Okay, this type of relation is called as a one to many relation or one to many cardinality. Okay, for example, scientists can invent many invention. One scientist can invent many invention. Okay, that is one to many invention. But invention, one invention is done by only specific scientist. But one invention is done by only one specific scientist. That is the one to many relation. Are you clear? Are you understood the concept? It's a request. Please join on time. It's quite disturbing while session is going on. So it's requested join on time. Yes, one to many. Is it clear now? One, one to many. One scientist can invent many invention, but the invention is done by the only one specific scientist. Huh? One invention is done by the only one specific scientist. This is the one to many relation. Now, many to one. Vice versa, opposite to one to many. An entity in A is associated with at most one entity in a B. At most one entity in a B. जास्तीत जास्त एका एंटिटीशी ती associated असेल. A मधली entity B मधल्या एंटिटीशी. Then entity in a B, however, can be associated any number. That is, it may be a 0 to n. Then of entities in a A. So it's called as a one, many to one type of cardinality. That is, students enrolls now. A, look at into the diagram A and B. Here, students enroll for a one course. Okay, but course can have many students. Okay, n number of students can enroll for a one course, but one course can have many students. This is the many to one. Okay, then many to many. As the name suggests, many to many. An entity in a A is associated with any number of entities in a B. Means both side 0 to more association should be there. Okay. And an entity B is associated with any number of entity in a A. For example, assume the students can take more than one course and one course can be taken by many students. Yes, of course. Um, Students can take more than one course at the same time and one course can be taken by the many students. This is the many to many cardinality. Is there any doubt, any question, query? Note down all these points. Please note down these points. Constraint, definition, types. Note down all these 4 points with the diagram. Over. Okay.